We can do another one of those big picture processes looking at, in this case, ER sorting, which once again we're in the cytoplasm to start with because that's where the ribosomes are, and translation begins at the cytoplasmic ribosomes. Undergoes translation arrest caused by SRP, recognizing the signal sequence, and that leads to a relocation of the ribosome to the surface of the ER, mediated by the SRP receptor interaction, at which location and at which time translation begins, and then you end up making the protein through translation through the translocon into the lumen of the ER. So I just want to do a quick video essentially magnifying this region and talking about mostly the topology of the co-translational translocation process that's accomplished by the interaction of the signal sequence on the luminal protein to be interacting with the translocon, and kind of how that all works spatially. So if we zoom in sort of like this, here is something that we refer to as a ribosome nascent chain complex, the RNC. Here's the SRP causing the translation arrest by interacting with the signal sequence. Here is the translocon. I've kind of exaggerated this opening, but the translocon is closed at this stage, and partly that's because of this plug that's built into the translocon structure itself. In fact, these two regions form a pretty tight seal on the other side as well that I just didn't draw very well. And there are negative charges that line the cytoplasmic side, so that's up here in this diagram of the translocon that are shown here. Here is the SRP receptor basically just hanging out in the ER membrane, waiting to encounter the RNC with the SRP, and that's what's going to happen in the next step. And that is that the entire mixture of the SRP receptor, ribosome nascent chain migrates over to the translocon. And there's kind of a check to make sure that everything fits correctly. And this is what I was talking about as far as that region of the exit tunnel, ribosome nascent chain, and translocon that have to fit like the USB port. So if that fit is incorrect, then GTP is not hydrolyzed. This thing just migrates away, and the process never gets to the stage of translocon. But if that is a correct fit, then what's going to happen is that the blue thing, the nascent chain, is going to enter into the translocon pore, and the plug that's shown here blocking that pore from the luminal side is going to flap back out into the lumen, allowing the nascent chain to move into the translocon and ultimately into the lumen. So, okay, that process is starting to happen here. So this is the nascent chain entering into the translocon, and if this is happening, then this has got to be the signal sequence. So let's go ahead and talk about what that signal sequence looks like, because it's important to keep that in mind to understand what happens next. So that's the N-terminus, and this is going to be a region that is ultimately cleaved by signal peptidase. So the rest of the signal sequence is one or more positive charges here, and then a bunch of hydrophobic amino acid residues here. And then the rest of the primary sequence of the protein, which can be as long as you want it. Doesn't make any difference. But these are the ingredients that we're going to use in the next few minutes. So as the translation commences now, once the contact between the ribosome and translocon has been approved, then the next intermediate that we would see in the process would look something like this. And that's because, as we just said, the signal sequence has those positive charges that precede a region of hydrophobic amino acids that would be right here now in this picture. So as a result of that arrangement of primary sequence elements in it, you have a hairpin that forms in the central pore of the translocon, while the translocon is undergoing a cyclic series of openings and closings to the membrane itself. So you can imagine a cyclic sampling of the phospholipid bilayer by the signal sequence that's going on as the nascent chain elongates into the translocon pore. And once that signal sequence is completely enclosed within the translocon, all those hydrophobic amino acid residues sort of add up to a region that's very happy to exist in the cytoplasmic membrane. So when in the next frame, what we'd have is something that kind of looks like this, in which the signal sequence that was in the translocon is now right here as a transmembrane helix. The positive charge of the signal sequence is right here, and where signal peptidase is going to cleave is right about here. So you could imagine some proteolytic activity, some protein with proteolytic activity is binding on that side and chopping right there. And as a result of that proteolytic process, we have what's called that N prime, the processed N-terminus. So then once that proteolytic event happens, we get the processed N-terminus, which is luminal. Translation can just proceed through the translocon pore, eventually making completely soluble and, one hopes, accurately folded protein right here with the help of course, HSP. 70-member chaperone called BIP, over here doing the Browning and Rashid, etc., and many other luminal chaperones that act on this thing to make sure that it folds correctly. The fate of the signal sequence is, I guess, somewhat controversial, but as far as we're concerned, it's done its job and it can be degraded with no further effect on the translocational process.